In these 3 screencasts, we'll work our way through an entire program design, from initially examining the information that we have to work with, through to a fully designed program. The information that we'll work with was published by the BC Provincial Government and contains information about the changes in BC's population from 1975 to 2012. Let's look at the file. We can see there's information about the migration to and from BC, both interprovincial and international, as well as a net change in BC's population due to migration. There's also information about the natural increase, which is the difference in population due to births and deaths, as well as a net population change for the natural increase. There's also a total of the population increase, which is the sum of the net migration increase and the natural increase, which, interestingly, has been positive every year since 1975. And there's a population for BC on July 1st of every year. Now that we know what information we have to work with, let's start working through the How to Design Analysis Programs recipe. We'll start with the planning steps. We've already described the information that is in the file, so I'll write that down in the notebook. First, I'll change the cell type to Markdown so that I can easily mark up the text to make headings and lists, etc. Here I've written down the information that's in that file, and I haven't run the cell yet so that you can see the Markdown that I've used. The hashtags in Markdown create headings in different sizes. The more hashtags you use, the smaller the heading will be. And I can use the dashes to create a list. When I run the file, you can see what it looks like rendered. Now we want to work on step 1B of the planning phase. And step 1B asks us to write a description of what the program will produce. The first thing we need to do is brainstorm some ideas. What could our program possibly produce, given the information that we have to work with? The program could find the average population increase between 1975 and 2012. It could find which year had the largest population increase between 1975 and 2012. It could find how many years had negative interprovincial migration between 1975 and 2012. It could find in which year was the population growth as a percentage of total population the largest. And of course, we could also brainstorm more ideas. We have to choose a focus, and while these questions are all interesting, we'll work on the last one. In which year was the population growth as a percentage of total population the largest? We'll run the file again to render this Markdown cell, and then we can move on to step 1C. So we need to write an example. This example will help us think about what kind of data we expect our program to produce. The example doesn't have to be correct. In order to ensure that the example was correct, or in other words, expecting the correct answer, I'd have to go through all of that file to find the correct answer, and that's what we want our program to do. We just want to make sure that our example will be of the right form. If I call main and pass it the file that has our information, named 2013 BC population change.csv, the answer that I expect back is a year. I don't know what the right answer is, but I know that it's a year. If I run this, we still have this as a code cell, so we're going to get an error because we haven't started building our program yet. Instead, we could change this cell to be a Markdown cell. This example will help us figure out what kind of answer we expect our program to produce. We don't need this example to run because we'll write more examples that will run for each function when we build our program. Now we'll move on to the building phase. Before I start actually building the program, the first step that I like to do is copy the template from the How to Design Analysis Program page. I'll delete the line that says it's a template, and I'm ready to start building my program. If I were to run this file, I would get a lot of errors because we have type names from the template that aren't defined, etc. But what I really like about the template is that it gives us a good place to start. While I work on the data definitions, I'm going to copy everything else, so everything from the functions down, into a new cell and comment it out for now. In step 2A, we need to determine which information we need to store as data in order to be able to answer our question. It's helpful to go back to step 1A at this point, as that's where we have the list of all the information that we have. Which parts of it do we need to store in order to be able to determine in which year the population growth, as a percentage, was the greatest. Our end goal is to return a year, so we know we need to store the year. With each year, we also need to store the population growth and the total population. That's enough information for each row, or for each year, to calculate the population growth as a percentage, so we don't need to store any of the other information. We also need to store information from many years, so we'll need a list type as well. If we scroll down and look at our template for the data definitions, we can see that we expect we might need a list type. If we were trying to answer a different question, we may have stored different parts of the information in our program. If we wanted to change our program in the future and answer a different question, we may have to make changes to our data definitions and our function designs. However, since we're following a systematic process, we'll be able to make any changes systematically and smoothly. So we need a compound data definition for a year's population change and a list of years. We know how to design these data types, so I'll paste them in rather than designing them as part of this screencast. Now I've pasted in the complete data definitions that we'll use for this program. I recommend that you take a moment and look these over. I'll run them to make sure that we have no errors.